problem number 11, they'd like us to find the average value of this function on this interval, but they say that we can use nint. Now, I never called it nint. The book calls it nint. What I call it is based on what the RTI calculator calls it, finite integral.
Yeah.
Okay, the nint, the n in nint, the first n in nint stands for numeric. The int for integral. It's basically saying using a procedure using breaking up the area into a bunch of small rectangles or other shapes, find out numerically the area under the curve. All right? So in this particular problem, we know that the average of the function is equal to b minus a times the integral from a to b of f of x dx, or in this particular problem, 1 over root 3 minus 0 times the integral from 0 to root 3 of x squared minus 1. Please know that officially you don't know how to do this problem yet, except by using the calculator. But let's go ahead and use the calculator for this. Now, I'm going to do a couple of things a little bit differently than perhaps the book would do. And that is, since the upgrade to the operating system, the ability to write fractions ends up being a lot easier.
What if you don't have that?
Then you should have it. And I think I did remember to bring the cable. All right. So under alpha y equals, there are a bunch of options. The first one is n/d, standing for numerator divided by denominator. And if you do that, you get a fraction form. 1, and then I'm going to do root 3, get out of the root, minus 0. Now, I really, like if I was doing this problem on my own, I wouldn't put the minus 0 in there. But I'm just trying to show that you can write complicated expressions. You don't have to worry about closing your parentheses if you use this fraction form on your calculator. Yes?
Thank you.
The 83 is not upgradable to this process. Now let's do the finite. Now let's do the finite integral, or the nit. Under alpha f2, there's fnint. It's option number 4, and then of course creates in our fill in the blank area. We're going to go from 0 to root 3 for the function x squared minus 1. And then our integral, our variable of integration is dx. So it ends up looking exactly the way I wrote it. And it looks like the average of this function is really close to 0. It is essentially 0. And they say, in the book, 0. Now why, it doesn't say 0, but why am I saying 0?
There's 14 zeros.
Yeah.
And then a number 3. Essentially, this is a round-off error. Remember, this procedure doesn't give us an exact value. It gives us a estimated value, and this is round-off error. All right, so there you go. There is problem number 11.
Woohoo.